So again, we're going to look at absolute values over 2 days. You're going to be able to solve equations involving absolute values as well as involving inequalities by the end of this chapter. So today we're going to start with a little bit of a simpler absolute value. We are going to begin by simplifying an equation. So your assessment recently, your quiz, involved solving equations. So we're going to still solve these equations here. So you have 5x minus 30 equals 40. Add 30 to both sides. You get 5x equals 70. To solve for x, you divide by 5. And we get x equals 14. We have 5b equals 6b minus 16 because we use the distributive property to distribute 2 to both parts. Subtract 6b. And we get negative b equals negative 16. Divide by negative 1. And you get b equals 16. And number 3, first you combine like terms. So I have a 2y and a 6y. So we get 8y equals 15 minus 2y plus 8. We're going to group the 8 and 15 together. So you get 8y equals 23 minus 2y. Add 2y to the other side. And you get 10y equals 23. Divide both sides by 10. And we get y equals 2.3. So we have some new vocabulary words. You have absolute value and extraneous solution. An absolute value is a distance from 0 on the number line. The absolute value of any number x is always equal to a positive x, whether x is negative or not. The solution to an absolute value equation can sometimes be untrue. That's called an extraneous solution. Okay, everybody good? Okay. Thanks for answering well. All right, so the absolute value of a real number is its distance from 0 on the number line. An absolute value of a real number is its distance from 0 on a number line. The absolute value of 4 1/3 is 4 1/3. Because it is the exact distance to the right as it is normally. The absolute value of negative 9.2, since distance is positive, is 9.2 from 0. The absolute value of negative 9.2 is 9.2. Absolute values are kind of like parentheses. You have to simplify inside before you take the absolute value. So we're going to take 3 minus 8, which is negative 5, then take the absolute value to get 5. A minus with absolute values do not turn to a positive. This stays 4 minus the absolute value of negative 5, which is 5, which gives negative 1. Is there a value of x in which you could take the absolute value and it equal a negative x? Yes. Perfect. Yes, there is one value in this whole universe, and that value is 0. Good job. At the beginning of the chapter, we started with evaluating expressions by plugging a number in for a variable. We're going to continue to do that now, but we're going to do that with absolute values. So we have 8.4 minus absolute value 2 times negative 7.5 plus 5. So again, absolute values kind of act like parentheses. You need to simplify what's inside before. So we get absolute value of negative 10, which becomes 10. So you get 8.4 minus 10, which is 1.6. Sorry, negative 1.6. Here we have absolute value 4 times negative 2 plus 3 minus 3.5. Absolute value of negative 8 plus 3 becomes absolute value of negative 5. So you get 5 minus 3.5, which is 1.5. Same idea. Plugging in your negative 2 for your x, you get absolute value of 9 times negative 2 minus 3 plus 5. So you get absolute value of negative 18 minus 3. So you have the absolute value of negative 21 plus 5. So that's 21 plus 5, which is 26. Again, it's good habit to get into boxing your answers in. It will make checking them much easier. Number 4, you have negative 3 absolute value. Plug in your negative 1 plus 1 all over 2. Well, negative 1 plus 1 is 0. Absolute value of 0 is 0. So you get negative 3 times 0 over 2. Well, anything times 0 is 0. And 0 divided by anything is 0. It's like asking if I could share 0 cookies with 2 friends. How many cookies does each friend get? Well, I have 0 to share, so they get 0. This is new notation. Function notation simply means that you're still plugging in your x. We can just write it a little different. So this is the same as saying f of negative 1/2. But you're still just going to plug in the value of negative 1/2 for x. So you get negative 3.5, which is like 4 times 3.5. So 4 times 3 is 12. 4 times 1/2 is 2. So 4 times 3.5 is 14. So again, if you want me to repeat that, I said 4 times 3. So 3 plus 1/2 is the same as doing 4 times 3 plus 4 times 0.5 because of the distributive property. So then you could do that mentally to get the 12 and the 2. So anytime you need to use mental math, you can actually use the distributive property to help you. It's like a mini lesson. This is actually what Common Core taught you and nobody liked. Okay, f of negative 2/3 is equal to 4 plus 2 times absolute value of negative 2/3. Absolute value of a negative is a positive. When you're multiplying a whole number times a fraction, you multiply the tops and the bottoms. So 2 times 2/3 is 4 1/3. To add fractions together, they have to have like denominators. So again, if you have no calculator, you multiply this by 3 over 3. So both bottoms are 3's. So you get 4/3 here, but this becomes 12/3. So 12 plus 4 is 16/3. You do not want to write that as a decimal. You want to write it as a fraction because 16/3 is a repeating decimal. And you can't actually write it as the decimal itself because it repeats forever and ever. Or you have to put the bar on top of the number. Oops. There we go. So your homework is the next pages in that book. You are doing the worksheet and the textbook problems 14 to 21. So the first page is that worksheet. The next page is the textbook problems. You need to do both. There will be an upload spot on Fusion. Sunday midnight. What? Yep. I always say midnight, but I think Fusion makes it be 11:55. Because if I actually pick midnight, it shows you the next day, and then everybody gets confused.